Welcome to the Active Filter series. In the last video, I derived the generalized transfer function for the infinite gain multiple feedback filter. We can use that function to generate a specific transfer function, in this case, the low pass, high pass, and band pass filter configurations. I'll just be replacing the general impedances with the resistance or the capacitance in Laplace form. In a later video, we will put these transfer functions to work and design filters. If you have watched some of my videos, you may recall that I made a pledge: no math steps left behind. Here's the generalized topology, and here's the generalized transfer function we derived in the previous video. This is a circuit for the low-pass configuration. I'm not going to restart the reference designators. Instead of making the capacitors in this configuration C1 and C2, I'll keep the same numbering to avoid confusion. So Z1 will become R1, Z2 will become the impedance of C2, which is 1 over SC2. Z3 will become R3, Z4 will become R4, and Z5 will become the impedance of C5, which is 1 over SC5. Here are the replacements. Z1 gets replaced with R1 in two places. Z2 will get replaced by 1 over SC2 in only one place. Z3 will get replaced by R3 in three occurrences. Z4 will be replaced by R4 in two places, and Z5 replaced by 1 over SC5 in one place. Now let's do some simplification. Eliminate the capacitor fractions by multiplying the numerator and denominator by SC and the capacitor number. Distribute SC5. Multiply the numerator and denominator by 1 over C2 C5. Several terms are canceled, and we get this. Rearrange to group terms with S and C2. There are three sets of S over C2. We can factor those out. Then rearrange the terms in the denominator to be in standard form. Now let's move on to the high-pass configuration. You can see the resistors have been replaced by capacitors, and the capacitors have been replaced by resistors. Z1 will become 1 over SC1, Z2 will become R2, Z3 will become 1 over SC3, Z4 will become 1 over SC4, and Z5 will become R5. Now let's replace the generalized impedances. Z1 gets replaced by 1 over SC in two places. Z2 will get replaced by R2 in only one place. Z3 will get replaced by 1 over SC3 in three places. Z4 will be replaced by 1 over SC4 in two places, and Z5 replaced by R5 in one place. Now let's do some simplification and get the transfer function into standard form. We can simplify these fractions, eliminate the capacitor fractions in four places, then distribute 1 over R5, combine terms with S to isolate S, and then factor out S. We can then add these fractions. To isolate S squared, multiply the numerator and denominator by 1 over C3 C4, then rearrange in standard form. Now for the bandpass configuration. Z1 will become R1, Z2 will become R2, Z3 will become 1 over SC3, Z4 will become 1 over SC4, and Z5 will become R5. Now let's replace the generalized impedances. Z1 gets replaced by R1 in two places. Z2 will get replaced by R2 in one place. Z3 will get replaced by 1 over C3 in three occurrences. Z4 will be replaced by 1 over C4 in two places. And then Z5 will be replaced by R5 in one place. Now for simplification. These fractions can be simplified. Then eliminate the capacitor fraction by multiplying the numerator and denominator by SC in the capacitor number. Distribute 1 over R5. combine the terms that have s, then factor out s. We can add these fractions together. Then to isolate s squared, multiply the numerator and denominator by 1 over c3 c4. Finally, factor out 1 over r5 c3 c4. In an upcoming video, we will put these transfer functions to work and design filters. Thanks for watching. Please click the like, subscribe, and notification bell so you don't miss any upcoming content.